Hey, let's take a look at number 21, part C. Now you have to read the directions for this problem very carefully because we're asked to evaluate this definite integral, but the way you're to do it in this problem is to graph the function you're integrating 4x minus 8 and then determine the value of this definite integral or interpret it in terms of signed area. So you're not using the fundamental theorem of calculus part 1. It's fine to check with that. We're also not using the limit definition for the definite integral, but the support for this needs to be done as per the direction. So make sure you're careful when you're asked to evaluate a definite integral, what method you're to use. So we sketch the graph of the function y equal 4x minus 8. And that's this red line here, right? You should recognize that that's a line of slope 4 and y-intercept negative 8. And so we see the y-intercept is at negative 8. And basically, if I go over 1, be careful here, the x-axis, each square is 1 unit. So here's 1, 2, 3, 4, 5, 6. But I've got the y scaled a little differently so that each block is 4 units. So this will be negative 8, this will be negative 4. And so if I go slope of positive 4 means I go up 4 over 1. Here's another point. Up 4 over 1. Here's another point, and so on. Or you can just check, for instance, if I plug 6 into this function, 4 times 6 is 24, and 24 minus 8 is 16. That's the height, that point right there where we're at 16. And of course, when we plug in 2, I get 8 minus 8, I get 0. So that's where it crosses the x-axis. But here's the graph of the function we're integrating. We're integrating from 0 to 6. So we interpret it in terms of signed areas. So notice from 0 to 2, the graph is below the x-axis. Therefore, this shaded in area between the x-axis and the graph will accumulate as negative area. That's why I put a negative down here. So it'll be negative this area of this, basically a triangle, right? And then from 2 to 6, the graph is above the x-axis, and therefore this area is positive, and this will be a rectangle, sorry, a triangle that will contribute positive quantity to it. So this will be negative, right? And the area of a triangle is 1/2 the base times height, so it's 1/2. I'm doing the base here is the x value, which is 2. Notice the height is the y value. Notice that's 8, right? 8 units this way. Keep in mind, remember, each square vertically is 4 units. That's 8 units. So it's 1/2 2 times 8. And then this triangle going from 2 to 6, that's a base of 4. So 1/2 4. And the height is obviously here. Hopefully you see that 16. So I go ahead and simplify these two expressions, add them together, and I get the value of this definite integral. So this is the support that you should show for this one. Granted, you could check multiple ways. You can check with your calculators, function integrator. You can check with that. You can, of course, use fundamental theorem of calculus part 1 if you know how to do that. You can even do the limit definition of the definite integral, which would be a little bit longer, but because of the nature of this function, and we can interpret these areas in terms, in this case, in terms of triangles, we can estimate the value of the definite integral this way. All right, I hope this is helpful for you. And as always, if you have questions, please let me know.